This is question 1 from round 1 of the British Mathematical Olympiad, January 1993. We need a 6-digit perfect square where the integer formed by the last 3 digits is 1 greater than that formed by the first 3. So 235236 is the form of this integer, but this is not one of those that we're looking for. So the integer that we want will be 1001 times ABC plus 1, and that is going to be a perfect square. In the work that follows, I shall let x equal ABC, but just to make clearer what we're now talking about, 235 times 1001 would be 235235, and if we add 1 we would get 235236, although as a 236, beg your pardon, although this is not the one we're looking for. And so if we look here, we will see that 1001x plus 1 is n squared, so that 1001x is n squared minus 1, which will be n minus 1 times n plus 1x. And now we come to the heart of the matter. 1001 is 7 times 11 times 13. So n squared will be congruent to 1 modulo 7, 11 and 13, and therefore n will be congruent to 1, or if you like 6, modulo 7, 11 and 13. And now 11 times 13 is 143, and 143 and 7 will have to be factors of n squared minus 1. 100,000 is less than or equal to n squared, which is less than or equal to 1,000,000. So 316 will be less than or equal to n, which will be less than 1,000. So this number, 1001x, will be n minus 1 times n plus 1, and we shall examine multiples of 143 in this range. We need to bear in mind later on that 143 is 3 mod 7. So if you look at this table, we will see that the candidates for n minus 1 are 429, 572 and 858, because they are the multiples of 143 between 316 and 1000. And the n's which those yield are 430, 573, 859. And in each case, respectively, n mod 7 is 3, 6, and 5. If we work out that 430 mod 7 is 3, because 143 is 3 mod 7, we can simply add 3 here as we compile this table, and then if the candidates for n minus 1 or n plus 1 also 429, 572 and 858, therefore these candidates for n which this generates are 428, 571 and 857, and we can just take 2 off each of these numbers here to get the n's mod 7, which are 1, 4 and 3. Now I said earlier that n will be congruent to 7 mod 1 or 6, and so we have 2 candidates for n, which are 428 and 573. Now, bearing in mind we shall be without a calculator, I've tried to set out a way of squaring these numbers which we might be able to use, and 428 squared turns out to be 183,184, which is a perfect square which has the required form. There we are. And this calculation here will give us 328, 329, which is the other one. The only real work you have to do there is to square 73, is to square 73. Once you split down those sums like that, you should be able to do it. On the other hand, it should be a relatively simple matter to square 428 by long multiplication. It's very much a matter for you how to do this, but that basically is the solution of this problem.